Hello and welcome to JLF's London 2020 Curtain Raiser at the British Library in partnership with the Aga Khan Foundation UK. Join me in welcoming Aga Khan Foundation's Global Director of Institutional Partnerships and CEO of Aga Khan Foundation UK, Matt Reed.
Hi, I'm Matt Reed, CEO of the Aga Khan Foundation in London. It gives me great pleasure to welcome you to this virtual curtain raiser for the Jaipur Literature Festival at the British Library. The Aga Khan Foundation has been supporting the festival for 6 years, both at its flagship in Jaipur, but also here in London at the British Library. Had we all been able to be together this weekend, we would have invited you over to the Aga Khan Center just up the street for the closing event and reception. I'm sorry we can't do that again this year. We had hoped that it would be an annual event, but we very much look forward to the time when we can all gather together and do that again. On the other hand, I hope that you enjoy the sessions to come over Saturday and Sunday. They give you a taste of the Jaipur spirit and help give you a sense of why the Aga Khan Foundation has been supporting the festival for so long. Its celebration of ideas, its promotion of pluralism, and its interrogation of important issues are more important today than they ever have been. And so I hope that you enjoy the next several days, get a taste of Jaipur, and that we can all be together in September at the British Library. Thanks very much.
Thank you, Matt. Thank you, Christopher Winton-Steer. And thank you to our colleagues at the British Library, Rory Stewart, Jamie, Conrad, John, and Bea. And of course, our supporters, British Asian Trust, British Council, and LSE's South Asian Centre. Remember, JLF London at the British Library Festival is scheduled for 11th to the 13th of September 2020, so do block your dates. And those of you who've missed any of our earlier sessions, including Myth and Memory, Amish and Namita Gokhale in Conversation, you can find these on our Facebook page, JLF Litfest, or on our YouTube channel, Jaipur Litfest JLF. Our next session today is Follow the Science, Venki Ramakrishnan in conversation with Roger Highfield. Nobel laureate Venki Ramakrishnan speaks of the importance of scientific thinking, of medical research and breakthrough technologies to combat the current crisis and better prepare for future pandemics. Venki Ramakrishnan shared the 2009 Nobel Prize in Chemistry for uncovering the structure of the ribosome. He is a senior scientist at the MRC Laboratory of Molecular Biology in Cambridge, UK, and is also the president of the Royal Society in London. Roger Highfield is the science director of the Science Museum Group. He has completed his 8th book, including After Dolly, The Science of Harry Potter, and his latest, Dance of Life, with Magdalena Zenica Getz. He writes for Wired and is visiting professor at UCL and the University of Oxford. Please do comment and ask questions by typing it into the comment section. And in case any of you drop off due to bandwidth issues, you can find us on our YouTube channel, Jaipur Litfest JLF. And of course, if we drop off, just hang in there and we'll be right back. Ladies and gentlemen, follow the science. Venki Ramakrishnan in conversation with Roger Highfield.
Thank you, Sanjoy. Wonderful to be back at JLF London. And it's wonderful also to be back with Venki as well. Venki, you're coming towards the end of your 5 years as president of the Royal Society. It's the world's oldest scientific academy. It ushered in peer review. It ushered in the scientific method, this dialogue between theory and experiment. And I think there's been something like 61 presidents since it was founded in 1660. So you're following in the footsteps of people like Isaac Newton and Ernest Rutherford and so on. So Adrian Smith's going to take over this November. Just remind me, Venki, how do you become the president of the Royal Society? Do you have a campaign and hustings and stick posters up everywhere, or how does it work exactly?
Well, I can tell you how it worked in my case. Somebody called me up and said, Paul Nurse is stepping down and, the Royal Society is looking for a new president. And I thought he wanted some suggestions of names. And I said, look, it's not our turn, because Paul is a biologist. And so they'll be looking for someone from the physical sciences. And I don't really know anybody in the physical sciences. And then finally he had to convince me that actually they were interested in me. And at first I thought he was sort of kidding. And then, when I found out he wasn't, I said I would think about it. And I suppose they were contacting a few other people in that way. And then a committee brings forward some names to the council, which is the governing body of the Royal Society. And then the council decides on a candidate, that's their top choice. And then what happens is this candidate goes out on a ballot paper to the fellowship in what I call a North Korean style election. Yeah. Because
well,
there's only one name.
This is an election with one name on the ballot paper.
Yes, I think it's more, you can think of it more as a validation or a confirmation rather than an election. It's to prevent the council from, appointing their friends or somebody who's totally, incompetent or something, But anyway, that is how it works. And they've somewhat changed. I think the process has become a bit more sort of transparent now, but it's still a North Korean style election.
So tell me, Venki, in your 5 years as president of this wonderful body, what have been the high points and what have been the low points?
Well, I have to tell you, before I say that, I have to tell you, when I was approached about becoming the president of the Royal Society, I actually didn't know a lot about it, except that it was this very distinguished organization. It had ushered in a lot of important advances, as you heard about the scientific method and so on. It was, in the early days anyway, it was a big forum for scientific debate and dissemination of knowledge. And I also knew about many of the early 20th century Indians had become fellows of the Royal Society. That was a big deal. Like Ramanujan, the mathematician, or C.V. Raman, who got the Nobel Prize for Raman spectroscopy, or Chandrasekhar, the astrophysicist. And so I regarded it as a great honor, but I thought it was more actually sort of getting there, meeting scientists, discussing things and so on. But of course, science has become a completely different enterprise today than what it was in the 1600s. Science was really a cottage industry done by, actually, I should say, white gentlemen, usually well-off gentlemen.
Yeah.
And it's very different now. It's what I would call the industrialization of science. And that means that the Royal Society is involved in a lot of things that aren't actually science, but they're about the administration of science or the sociology of science. For example, making the case for science to governments, having relations with other academies, public engagement, issues like gender equality and so on, which are not directly about discoveries or about actual science, but about the process of science and the organization of the science enterprise. And science policy is a big, aspect of the Royal Society, about which I really knew nothing at all. So it was a fairly steep learning curve. And while I was on the ascent of this learning curve, the British people, in their infinite wisdom, decided to leave the EU. That was 6 months into my presidency, with this referendum. And that had all these implications for our collaborations with Europeans about, funding and collaborative schemes, all sorts of things, and mobility. So, I became heavily involved in what I would call science politics. I had to talk to, I've had dinner with people like David Davies and Steve Baker and others, and who were part of the original Brexit department. And I've had constant interactions at various levels. And
so, Venki, you better clarify. Are you talking as Brexit as the high point of your presidency, or dare I say, the low point of your presidency?
I would say my presidency was sort of derailed by Brexit.
Right.
And just when we were thinking that, okay, Brexit is going to come to a conclusion, we've now left the EU, there's a transition period, the negotiations are going to go on, and hopefully we'll get some sort of deal. Suddenly, this pandemic hit. And of course, everything stopped. The country was in lockdown. I actually had to shut down, I initiated a shutdown of the Royal Society. And so the fact is, so now all of my time is involved in, convening this group, that deals with the pandemic and attending, advisory meetings on the pandemic, etc. So now, you might think of me as a B to C president, the Brexit to COVID president. And my other agenda is about, broadening our education and public engagement and international relations. Unfortunately, I've taken a bit of a back seat, during my.
But before we dive into COVID, Venki, what was the high point of your presidency, do you think?
I think for me, the high point was meeting people that I would never meet normally. I mean, I suppose once you've been awarded a Nobel Prize, it opens doors and you can meet people outside your field. And I could have done that, but that requires an active effort on your part. But if you're president of the Royal Society, it just happens naturally. And you meet all sorts of people from different walks of life. I've met brilliant people from all walks of life. I've also learned an appreciation of how science works, a sort of 30,000-foot view of how the scientific enterprise works and what the key issues are, etc. And, and I've learned about how government works and how, people in their ivory tower often have contempt for politicians and, government officials and so on. But actually, I found many of them are actually quite thoughtful. It's just they have a different set of criteria and different constituents that they have to answer to. And so they, also require convincing, just as you're in peer review, you've got to convince people that your paper is correct. These people also want evidence, and they don't want you to just go there and sort of bang the drum. And so that's also been educational.
I know the society is full of the finest scientific minds. Throw a stone in the Royal Society and you'll hit a Nobel Prize winner. I'm sure there's a phrase like that out there somewhere. But you've set up a couple of committees to look specifically at the pandemic. I think one's called DELVE, Data Evaluation and Learning for Viral Epidemics. And then you've got one called RAMP, which is looking at modelling. Give me a sense.
The British love acronyms, as you know. And that's so another thing. One part of my 4.5 years is constantly figuring out in any document what this acronym is. But anyway, go on.
What I find fascinating is that I think one of the very first things you looked at was the vexed issue of face masks.
Yeah,
and we were talking about this the other day, and I think it sounds quite mundane at one level, but when you look into the enormous argument about the public health benefits of face masks, it does give you an interesting insight into what do we mean by evidence and so on.
Yeah, the face mask is a real eye opener for me. Okay, and I have to tell you, part of it is a kind of, I wouldn't say groupthink, but let me backtrack. Naomi Oreskes recently had a conversation with Nick Stern at the Hay Festival on her new book, Why Trust Science. As you know, she wrote this book called Merchants of Doubt. That's what she's most famous
for. And Nick
about.
Stern did the famous Economics of Climate Change report a few years ago. So he's quite familiar.
Exactly. Well. So what Naomi said is that, the science doesn't work because of a particular scientific method. It works because people challenge things using different methods. And that's what gives science its sort of reliability. And she specifically mentioned randomized controlled trials. Now, the argument about face masks is that a lot of people in Britain, especially in Britain, but elsewhere as well, but I would say particularly in Britain, because the RCT is a British invention and they're justifiably proud of it, okay?
Yeah.
And so they have this feeling that if something isn't established by RCT, then the evidence is weak, okay?
Yeah.
Now, the problem is, there are lots of things which in randomized controlled trials work very well for pills, where you can give a pill or a sugar pill or a medical pill to different groups, and you see, you know, which one, if there's an effect, okay? But even with pills, I should tell you, there was an issue, and where randomized controlled trials have a problem is compliance and behavioral problems. It's much less effective when there's question of behavior and compliance. And with TB, randomized controlled trials didn't actually work until they used what's called DOT, directly observed therapy. In other words, the healthcare worker had to watch the patient every day pop the pill. Then
actually, I'm
not
surprised with TB, because I seem to remember, Venki, you've got to take an enormous number of pills, haven't you, to finish your course?
6 months, okay?
Yeah.
And that was a problem. So they had to adopt randomized controlled trial to make sure that compliance was not an issue. They had to adapt it. So, you know, with face masks, the problem was that the few trials that didn't have a great signal.
Yeah.
And but when they corrected it for people who actually wore the mask, there was actually a strong signal. But they sort of dismissed that, saying, oh, we can't do that because, you know, in a real world, you have to account for people who wouldn't wear masks. Now, in a trial, they're not at risk of dying or catching a terrible disease. Of course, compliance is not going to be as high. Secondly, everybody advocates hand washing, but I investigated the hand washing issue. If you look at viral respiratory infections, the evidence for hand washing doesn't have very good RCT evidence as well. You know, nobody would say don't wash your hands. So this is really a kind of weird prejudice on the part of certain scientists.
Yeah.
And when you look at the mechanics of it, you know, we all expect surgeons to wear face masks when they operate on someone because they don't want to infect the wound, you know, the surgical opening, and infect the patient. You wouldn't want to be operated on by a surgeon who wasn't wearing a mask. So, you know, that there's no randomized controlled trials for that, where, you know, half the surgeons wear masks and the others don't. So it's a bit of nonsense, actually. And I think, you know, when we're having trouble bringing the case rate down to a very low level, hospital infections are a big problem, care home infections are a big problem, and above all, asymptomatic transmission is a problem. So you don't know when you've been infected. So you can't isolate yourself before you're infectious. Then I think wearing a mask is good precautionary medicine, you know, and it's a way of it's not perfect, but it's a way of reducing the probability of infection.
What other issues have you looked into? I seem to remember immunity and track and trace and things like that.
Yeah, so, you know, track and trace. Well, you know, the Prime Minister said we have a world-beating system. Well, but the reality is there are a lot of issues with, you know, track and trace. And one of the key issues that the Delve group came up with is that you have to, first of all, make sure that the time between the development of symptoms and a confirmation by a test, that needs to be brought to a very bare minimum, you know, preferably a day. And because during that time, you've got to inform all the contacts and keep those contacts isolated. Now, most of the index cases will turn out to be negative. So you don't want these contacts hanging around forever. Otherwise, they won't bother, you know, they won't take part. A lot of it depends on compliance, you know. So I think those are some of the issues. And also, how do you define symptoms? It turns out, you know, a lot of symptoms can be confused, but oddly enough, one symptom, the loss of sense of taste and smell, turns out to be a very strong symptom of COVID. Okay.
That's a really interesting, I think it came from this King's college app that I think more
Absolutely.
than 3 million people downloaded, and it
Absolutely.
gave very vivid insight, didn't it?
Yeah. So again, as we get data, we're better able to, characterize what is a symptom, and also what is a contact. If you pass somebody, in a hallway, is that a contact? Or do you have to be indoors for 15 minutes? What if you're outdoors for 15 minutes? So, and what sort of distance? Things like that. So it's nothing is trivial in any of this.
I think also, we have seen some amazing examples of how track and trace can be conducted. For example, in South Korea, where they don't use an app, the government just has access to mobile phone and credit card records. And I think it's rather staggering. Within about 10 minutes can figure out where you've been, who you've been in contact with. I know
they have this giant network of everybody's movements, and then they look for proximities. I think if that could be done here, it would certainly work. But that raises all these questions about civil liberties and.
Well, I was going to say, how much civil liberties? I personally, I think, given the death rates in the UK at the moment, where it's somewhere between 40 and 65,000, depending on who you believe, I think that's
it's well over 60,000.
Yeah. And in fact, even the issue of immunity, I know we got very fixated about this phrase herd immunity, but we still don't know how long that precious immunity will last. Gosh, I hope you're okay, Venki. By the way.
Yeah, no, I'm fine. I have allergies. Don't worry about it. I couldn't possibly have caught anything because I've not been anywhere. So, no, what were you saying about herd immunity?
The immunity question is absolutely fascinating, isn't it? Because we still don't really know how long that immunity, whether it develops well enough to protect you from a second encounter. It probably does, but then how long will that protection last for? Yeah,
I mean, these are questions that are only just emerging with now that we have good serological tests. What we can do is follow up people who've been infected, some of whom will have no symptoms or very mild symptoms, and others who've had serious infections. And as with other SARS infections, it is looking as though if you have a very mild or asymptomatic infection, your titer of antibodies is quite low. And if you have a serious infection, it's higher. But the question is, even if you have low antibodies, are you still immune? We don't really know the answer, although that's emerging very quickly. And then, of course, there's a question of how long the immunity lasts and how you would characterize somebody who's immune versus not. And so these are all, immunological questions that are being studied. The herd immunity was based on the premise that, you would get immunity if you got infected, which, we still have to establish, and that you'd be able to protect the vulnerable. But the point is, there are two things about protecting the vulnerable. You have to identify who the vulnerable are, and they're not just people who are old. For example, the median age of people who died from the BAME community, that is Black and minority ethnic, is 51 or something like that, versus 69. Median age of people who got serious infection, not died, but who got serious infection. And so you may have other factors that make you vulnerable, and we don't know all those yet. It's not strictly age. And the second is, for example, we didn't know about asymptomatic transmission when this first came out. And so you wouldn't know whether you were protecting the vulnerable. You might be infecting the vulnerable. So I think it was not a well thought out strategy. And, not that it's in principle an irrational kind of strategy, but it was, I would say, premature because we didn't have all that information.
Well, I suppose we now know that, let's say, if we're conservative, less than 10% of the UK population's been exposed to coronavirus. We've got more than 60,000 deaths. So if we expose the other 90% of the population to achieve, greater immunity, there would be a very heavy price to pay for that.
Exactly.
And I suppose But
exactly.
you're a member of the Scientific Advisory Group for Emergency, SAGE, which has been advising the government. And even today on a well-known UK TV program, we had one of your fellow SAGE members, John Edmonds, saying that he thought lockdown happened a bit too late and that cost lives. I think that came up in a Channel 4 dispatch.
I would agree with John Edmonds. I would completely agree with John Edmonds on that. I think, I don't understand why there was a delay in the lockdown. One could argue they were waiting for results of modeling and so on, or possibly got sidetracked by the whole herd immunity idea. But the point is that one didn't need modeling. It was clear what was happening in Italy, and they were about a month ahead of us. And so I think the period of the lockdown would not have changed. So this idea that you'd get lockdown fatigue makes no sense at all, because if you lock down early, you also come out early. So I don't. There are some things I don't understand, but I wasn't privy to any of those discussions.
It's exposed a very interesting issue about the relationship between scientific advice and government, and it became almost a mantra that the government said they were following the science, or this was done in line with scientific advice. Just talk us through. I mean, I suppose what worries me.
I think that is I think following the science is somewhat misleading, because there are often questions where there is no scientific consensus. For example, there are people who believe face masks are worthwhile and should be adopted, and others who are very skeptical. So the solution is not some middle ground where you say you wear a little bit of, do a little bit of it. You have to decide, which one you want to adopt. And similarly, for many other things, there's a range of opinions. And it's not surprising that, the people agree broadly on things about how coronaviruses behave and, about transmissibility, etc. And yet different governments have had completely different approaches. New Zealand had one approach, Korea, Taiwan, Hong Kong, they've all had rather different approaches. And Sweden is out on it, doing its own thing. It's doing the herd immunity thing effectively. And so I think this shows you that there's a difference between what governments implement as a matter of policy and what the science advises. So that's one thing. The other is that scientists, like everybody, can make mistakes or misjudgments. They're not, you wouldn't call them necessarily mistakes, because they were based on the best available data at the time, but the data keep changing and new data comes in, and then they have to reevaluate and so on. And so if you want scientists to really give you honest advice, their best estimate of what's happening and what ought to be done, you can't then blame scientists later. Because then if scientists know that they're going to be blamed for their advice, they won't be frank with you. They'll try and be ultra cautious and cover their backs and so on. And so that's not a healthy situation. And so I was going to
say, this is such a tricky situation. It's in effect a new disease, probably came from bats or pangolins, or something to do with bats and pangolins. Yeah. Obviously, the scientific understanding is emerging now. And, the motto of the Royal Society, take nobody's word for it. So there's lots of stormy arguments among scientists. How worried are you, though, that this simple characterization of us following the science will actually backfire and will tarnish the image of science?
I think it's twofold. One is the government should admit that it's implementing policy, it's getting science advice, and it's deciding how to take that advice, okay? And, there's a famous Thatcher saying, advisors advise and ministers decide, okay? And so it's the ministers who are ultimately responsible for any policy. At the same time, I think scientists should be very open about how science works. Science is based, at the frontiers, things are not certain. And scientists need to be open about the uncertainties, about the range of uncertainties, the range of opinions. They also need to be careful to avoid groupthink and have a really robust discussion and be challenged, So I'm not opposed to, people outside SAGE expressing opinions and expressing, challenges, etc. I think that's healthy. And, if that had happened in China in the early stages of the pandemic, we might be in a different place, okay? So I think transparency, openness, robustness of argument, and finally admitting when you got things wrong and learning from that how to improve the process. I think those are the ways to go forward rather than engaging in some sort of blame game. Okay, because science has always been uncertain at the frontiers. It's just the pandemic has, brought that into the public eye.
Now, I think before we take questions from the audience, we've got just a few more minutes to go. And I'd like, Venki, just to focus on the virus itself, because, of course, you're a member of Britain's Nobel Prize factory, the Laboratory of Molecular Biology in Cambridge. You got your Nobel Prize there yourself. And at the moment, there's a lot of really interesting projects there looking at the virus itself. And just for those who don't know, the coronavirus, it's 125 nanometers across, that's 125 billionths of a meter. You can't see it with an optical microscope. You can only see it with an electron microscope. It's just got 29 proteins. Only some of them actually make up the virus itself. The others help it come into being in human cells. It's just this scrap of genetic code wrapped in an overcoat of fat and protein. So, Venki, I understand you're looking at NSP1, non-structural protein 1, and trying to understand what that does in the virus.
Yes, well, it's interesting. This is a virus with only 30,000 letters or so in its genetic code. It's an RNA virus. So its code is RNA rather than DNA. And yet it's brought the entire world to a standstill. And we humans have 3 billion letters in our code. And we seem sort of helpless, against this little package, of disaster. But the 30,000 letters code, as you say, for about 30 proteins or so. And they do various things. One of them copies the viral RNA, so it's essentially to replicate the virus. Others code for proteins that make up the viral coat. Others code for proteins that make spikes that sit in the outer surface of the virus and allow the virus to attach to our cells using a certain receptor on our cells. So that all of these are drug targets. And then the 30 proteins are not made as individual little proteins. They're made sometimes as one large string that's then chopped up. But the chopping up is also done partly by a viral protein called a protease. Now, many viruses have this polyprotein that's chopped up, like HIV. And the protease of HIV is a drug target. The polymerase inside HIV, which copies HIV, is also a drug target. Yeah. So you see, each of these proteins is a drug target, and knowing their structure is going to help pave the way for getting drugs. Now, my lab had a short-lived attempt to understand this protein called NSP1, which somehow shuts down the human ability to make human proteins, but allows the virus to carry on making its own proteins by blocking the ribosomes in a very specific way. So it's a ribosome problem. Unfortunately, I was scooped by a very eminent scientist in Germany who just came out with a preprint of exactly what we wanted to do, but there's still more to be done. For example, we don't know how that protein allows the viral proteins to be replicated. We know now how it might stop human proteins. So there's lots of work going on, and this work will help, these kinds of structural work will help design better vaccines, understand the biology of the virus so we can target it in different places for drugs, and just generally see how it, behaves and, understand its biology better.
And I suppose actually to put it in a rather crude way, people don't realize that the virus depends hugely on human cells to reproduce, to make more viruses. And
Yes.
so if you attack the virus, it's quite difficult to do it without causing collateral damage on the human cells. So this is why we need this incredibly detailed understanding, so we can come up with kind of, in effect, surgical approaches to attack the virus without harming ourselves in the
Absolutely.
process.
And that's true whether it's a vaccine or a drug. You want it to very specifically target just the viral proteins or pockets in the viral enzymes that stop it from working without being toxic to us or causing side effects to us. No, that's a very important point. So when people, just to add one thing, people complain about, whether scientists got this right or that right. What they're forgetting is how amazing is it that we knew nothing about this virus in December. We knew nothing about the disease, okay? We not only in a short period of a few weeks figured out what was causing the disease, isolated the virus, sequenced it so that we know the sequence of its 30,000 RNA nucleotides, figured out all its, proteins that it's making, etc., which paved the way for a test for infection. It paved the way for an antibody test. It's paving the way for vaccines. It's fantastic. This is unprecedented pace of discovery. And that shows you how molecular biology and, biotechnology and medicine has advanced so tremendously in the last few decades. And that's a result of investment in science. So one mustn't undervalue what science has already done, for this pandemic and what it will do eventually in terms of producing solutions.
We've got a couple of questions here from the audience. Aditi asks, what's your opinion on the COVID curve in India and the way that the pandemic is developing in India? I don't know whether you've got the latest statistics, Venki.
I don't know, but the only thing I have heard is that the lockdown arrested the rate of growth, but it's still growing in India, as far as I know. And that is, a worry because it hasn't been, completely, squelched yet. The curve has not been, completely flattened or scrunched. It's been flattened, but it's still on the ascending slope.
Well, in fact, that leads very nicely to a question from Rachita, who says, now the lockdown is being lifted in India. Do you think that's, in effect, a denial of scientific thinking? It feels a bit early.
Well, the same question is being asked in Britain. And the problem is politicians, there is a public health and science view, which is that one should only come out of the lockdown when things are manageable. For example, if the case rate is low enough that you can have testing and tracing and isolate clusters, quickly identify clusters of new infections and isolate them and so on, then, you can have a sort of stable, emergence from the lockdown. And if you have a very high caseload, those things all become harder. So what is the point in which you have to emerge from the lockdown? Now, politicians get advice from scientists and public health people on one side, and then there are people in the business world and the economists who are very worried about the crashing of the economy. So this is a political decision, not a scientific question. And each politicians will decide, based on their own sort of judgment of what they think is best, I think.
There's a question here from Sachdev. Dr. Ramakrishnan, yours is an extraordinary life of a PhD in physics that transitioned into biology and onto biochemistry. Could you speak of the key influences in your life, people like Aaron Klug or Richard Feynman, who may have made the difference to sort of inspiring you to greater things, as it were?
Well, I had a lot of inspirations. First of all, I came from an academic family, and my mother, for example, encouraged me from a very early age to read very widely. And I underappreciated it at the time, but the older I get, the more I realize that, that was part of my sort of intellectual development. Then I also had excellent teachers, some of them, one in high school, but also people who had come back from the US to accept relatively low-paid positions as faculty members in my local university and modernized curricula, etc. So I had a number of inspirations like that, and of course you read books. I read a biography of Marie Curie early on. Here's this Polish woman who went off to France, and in a heavily male dominated society, and also foreign society, to make her way in science was pretty remarkable. So there were lots of such influences. And of course, I was influenced by Indians who had done well, because that sort of showed you could get an education in India and go on and achieve things. Chandrasekhar, the astrophysicist, or Ramanujan, whom you and I have discussed, who never even went to university and or never finished university. So I think there were a lot of influences like that. But ultimately, you have to think of them as just inspiration. They're not a guidebook to tell you what to do. Okay, they're simply a sort of way of saying, look, it's sort of possible, but you have to figure out your own way.
So Venki, here we are. One more quick. I've got two more quick questions for you. Om Prakash asks, you believe that a second test of a recovered COVID patient is going to be a game changer. Can you elaborate? And does a fully recovered person?
Yeah, I'm afraid I was a little premature when I said that. Okay, because I was being optimistic about serological testing. What I meant was that if you have a test for people who have already had the infection and recovered from it, then you can, for example, ask questions like what fraction of people who are infected develop antibodies, what fraction develop immunity, things like that. That's really what I meant. And that's only just now beginning to happen.
Yeah, and I think with the antibody tests, if you've got relatively small amount of COVID in the population, I think if you have false positives, it's quite hard to figure out what's going on with some.
Although some of the new tests are much more reliable. The problem with the early tests is they had a high rate of both false positive and false negative and cross-reactivity. That's part of the false positive. So, but the newer tests are more specific and have fewer of those issues.
So Venki, a year ago, we met up at the British Library to talk about your book, your wonderful book, Gene Machine, which I really enjoyed, which is about your Nobel Prize quest to crack the secrets of the ribosome, which is this amazing molecular machine that turns genes into flesh and blood. Now, I presume from what you've just told me that your follow-up book is going to be Non-Structural Protein 1, How I Lost the Race to Crack SARS-CoV-2 or something.
You're teasing me, Roger, because you know damn well what I'm trying to write about. So I thought, what would be an interesting problem that would be of general interest, and I thought, the question of why we die. Okay, and I don't mean die of a disease or die in a car accident, but even if you're completely healthy, you can't expect to live more than 130 years. On the other hand, some species only live a couple of months and others live several hundred years. And so what is this process of aging and death, and what is that due to? And then there are people now who I call the sort of merchants of immortality, who are trying to have these programs to live forever and so on. What is that all about? Are these people charlatans, or is there something there? So I'm looking into the whole issue of, is death necessary? The biology of why we age and how we die. Or how we age and why we die. So I thought that would be an interesting thing, and it has a lot of things in it, like fundamental molecular biology and biochemistry and so on. But it also has a lot of sociology, about why people are, people have always been worried about death, ever since humans know about. Humans perhaps are the only species that are aware of our mortality. Animals know when a fellow animal has died, but they don't know that they're all going to die one day at a certain age. We're aware of our mortality, and that has influenced civilization and culture and so on. So I thought there'd be an interesting mix there.
I think that sounds exactly the kind of book we need to read at the moment. We all need something that's optimistic, that's glass half full rather than glass half empty. And I think is Death Necessary going to come out later this year or next year?
No, it'll be about 2 years, I would say.
2 years.
Possibly the end of next year, end of 2021 is what I'd hope for.
Well, I think on that lovely optimistic note, let me hand back to Sanjoy, and just to say, Venki, what an incredible pleasure and honor it is to chat with you again. Thank you.
It's been a real pleasure, Roger, as ever.
Thank you.
Venki, do you want us to suffer our governments till we're 130? Seriously? I mean, what?
No, actually, so my view is that one should not extend life. But what one should do is extend the fraction of our life that we're healthy. In other words, try to avoid this really long decrepitude of old age. That's what we should be aspiring for, not to extend lifespan itself.
Yeah.
Well, we need to have that fascinating conversation. And what has inequity got to do with that? And
absolutely. There'll be a lot of things like that.
All of that, I think, is something that looking forward to this particular book. And I hope the minute it's done, you will be back at the Jaipur.
Well, I'd love to, especially if you'll have me in Jaipur, I will certainly come.
Absolutely. I mean, I hope COVID, this 33 whatever RNA thing allows us all to get back to some semblance of normalcy in the.
I'm fairly optimistic. I think, with most pandemics, a solution is found. We have very powerful tools now, so I'm hopeful that eventually it'll happen. I don't like the hyping that people have that it'll be ready by Christmas or things like that. I think that's being over optimistic. But I think with careful public health,
it's been both the fear factor and the hyping. Both have been problematic. The fact that people learn to live with it, as you said, wash your hands, take the precautions, etc. That's the most important message, at least in the interim.
Yeah, and I have to say, some of those health measures will be good to do forever. For example, when I was growing up in India, nobody shook hands. Okay, we all did this. Okay, and then somehow, it became this cool thing to do because the Westerners were shaking hands. So Indians all felt, oh, we have to shake hands too. And I think that Indians had learned the hard way that you shouldn't touch each other unless necessary, okay? And so some of those things really need to come back. We need to maintain a certain public health and hygiene, and that'll be good in the long run, even because it's much easier to prevent diseases and much more expensive to treat them than to prevent.
But how will the Italians and the French survive without kissing each other?
Well, they'll have to learn.
Well, thank you both. I mean, it was incredible, and you're always incredible. And Roger, thank you for.
Well, Roger is a fantastic conversationalist. He and I have go back to 2001. So he's known me long before anybody else.
No escape from me, Venki.
And congratulations on the 5 years at the Royal Society, and hopefully, that tradition will continue, and whoever takes over from you will continue to sort of pioneer on. And thank you all for watching and being such a great audience. I'm sorry we couldn't take all the questions because we just ran out of time. And in this case, the questions weren't just a yes or no answer. These were considered questions and would have to have very considered answers. But perhaps if you send them to us, we will forward it to both Roger and Venki and ask them if they'll be kind enough to answer these, and we'll post them on Facebook. Remember, JLF London at the British Library will be back 11th to 13th of September. So do block your dates. That's the time for the actual festival. And we hope to see you there. And meanwhile, from next week, we return to broadcasting our weekly online series, JLF's Brave New World. So remember to log on 10th of June. We will present The Governance of the Unprepared, Homi Bhabha in Conversation. At a time of global pandemic and a century which has seen turmoil and progress in equal measure, the one feature that stands out is how unprepared the human race is for both man-made and natural calamities. Scholar and critical theorist Homi K. Bhabha from Harvard will share his views, and this will be 7:30 p.m. Indian Standard Time, 3 p.m. British Summer Time, and 10 a.m. Eastern Daylight Time. The next session on the 10th of June is an Orchestra of Minorities, Chigozie Obioma in conversation with Aruni Kashyap. Chigozie Obioma, the Nigerian writer, described as the heir to Chinua Achebe, is the author of The Fisherman and an Orchestra of Minorities, which was shortlisted for the Booker Prize in 2019. Told from the perspectives of the protagonist, Chinoso's 700-year-old chi, or spirit in the Igbo tradition, the novel speaks of the mythologies as well as the realities of love, in conversation with writer and academic Aruni Kashyap. This will be at 9 p.m. IST, 4:30 p.m. British Summer Time, and 11:30 a.m. Eastern Daylight Time. And now, to end, we present a short extract from the archives of the Jaipur Music Stage featuring Purbayan Chatterjee. A recipient of several prestigious awards, is an acclaimed sitar maestro. He belongs to the Senia Mahiyar Gharana, founded by Baba Alauddin Khan, the guru to Pandit Ravi Shankar and Ali Akbar Khan. Enjoy the music. Thank you all for staying tuned in to JLF at London British Library. See you all on Wednesday.